In our last video for week 5, we're going to review a couple of examples of how to perform a hypothesis test for claims about two proportions. For our first example, it says, in a random sample of 80 Americans, 44 wished that they were rich. In a random sample of 90 Europeans, 41 wished that they were rich. At alpha equals 0.01, is there a difference in the proportions? And we're going to skip the finding the 99% confidence interval, as we reviewed that last week. And we're just going to do the hypothesis test. So we'll start by defining our parameter. In this case, we're talking about proportions. Is there a difference in proportions? So these are P's, P1 and P2. So P1 is the proportion of Americans who wish they were rich. And then P2 is the proportion of Europeans who wish they were rich. And we're going to go ahead and organize here. So we are told we take a random sample of 80 Americans, and we get a sample success of 44 who wish they were rich. For Europeans, sample 2 was 90 Europeans with a number of successes of 41. And then I am told my significance level is 0.01. We're going to assume that the conditions for this have been met. I should check n times p and n times q for both samples, but for the purposes of the textbook and your test, you may assume those have been met. And I'm going to perform a two-proportion z-test. I know it is a z-test. I'm going to set up my hypotheses and then set up my distribution so I can find my test statistic and p-value. So I'm comparing proportions P1 and P2. The assumption is they are equal. We're asked to test the claim, is there a difference? So the alternative is not equal. I'm going to draw my z distribution. And then I'm going to find my z test statistic and my p-value using my calculator. So stat tests, and I want 2-prop z-test. 2-prop z-test. And I'm going to jot down what that's asking for on my paper. This constitutes me showing my work. So 2-prop z-test asks for x1, n1, x2, n2, and then it asks for the alternative, p1. So we know successes for Americans was 44 out of 80. For Europeans, we had 41 successes out of 90, and we are testing a claim of not equal to. And we're going to go ahead and go down to draw and see what the calculator says. Uh-oh. Did I forgot to put the values in the calculator, didn't I? It's been a long day. There we go. So we get a test statistic of 1.23 rounded and a p-value of 0.219. So in my picture, I'm out just past one standard deviation on either side, negative 1.23, positive 1.23, and my p-value is composed of the area in those tails. Because our p-value is much, much greater than our alpha, we are going to fail to reject the null. Our samples are not different enough for us to feel confident eliminating the claim of equality. Our samples are too close together, proportion-wise, to eliminate that null in support of the alternative. Let's go ahead and try one more example. It says, a recent random survey of households found that 14 out of 50 householders had a cat and 21 out of 60 householders had a dog. At 0.05, test the claim that fewer household owners have cats than household owners have dogs. So, I don't know why I wrote mu there. We're testing claims about proportions. So P1, P2. We're testing for P1 the proportion of householders who had a cat. And then our second group is the same. We're testing for the proportion of householders who have a dog. I know I'm asked to perform the test at alpha equals 0.05, and I'm going to go ahead and list sample successes and sample size. And looking at my definitions at the top of the problem, I defined group 1 as cat and group 2 as dog. So for group 1, 14 out of 50 had cats. For group 2, 21 out of 60 had dogs. Since I'm testing a claim about a proportion, we're assuming that n times p and n times q are greater than or equal to 5 for both samples. We're going to go ahead and start a two-proportion z-test. I need to state my null and my alternative. So claims about P1 versus P2, P1 versus P2. The null is always a statement of equality. And my alternative, I want to test the claim that fewer households have cats. Cats fewer than dogs, so that's cats less than dogs. Cats is 1, so 1 is less than 2. That's the claim we're testing. Fewer cats than dogs. P1 is less than P2. So we'll go ahead and pull up our two prop z test. We know from the previous problem it asked for xn, xn. So x1, n1, x2, n2, and then it's going to ask about the alternative. So we have 14 and 50, 21 and 60, and a claim of less than. And we know this is a z-test. And we're going to get a test statistic and p-value out of our calculator. You'll notice our picture looks a little different. We're given a test statistic of negative 0.78 rounded, and a p-value of 0.2163, or about 22%. Negative 0.78, that's within 1 standard deviation of the mean. And I'm shading to the left because this was a less than statement. I shade in the direction of that inequality. In this problem, my p-value is much greater than my alpha, about 4 times greater. And when my p-value is greater than my alpha, I fail to reject the null. Since I'm failing to reject this, there's not enough evidence to support that. So I do not have evidence to support the claim that fewer household owners have cats than household owners have dogs. If you have any questions on what you saw in the video, feel free to send me an email or drop by office hours. Otherwise, I will see you next week.